Right, so average velocity, if acceleration is constant, you just average the first and the last one, so you add them up, divide by 2. Average speed, because in that problem, you're changing directions, because the velocity is positive in one place and negative in another, so that means you change directions. So to find average speed, you would figure out the distance traveled, which I do ask, and divide by the time. Right, did that answer your question?
Yeah, thank you so much.
Any other last moment questions?
Are we able to use notes?
Pardon?
Are we able to use notes?
Not if you want to pass.
Um,
Yeah, it's not an open book test.
Can we write somewhere? Because I think we need this stuff and it's not included in
VO or VI, which one?
VO and plus acceleration time. And can we have displacement formula also?
What was the?
Like this
That one?
and this, like we did not have it in any test.
Right, so displacement. There we go. And with those 3 equations?
Yeah, thank you so
ordered?
much. That's
Okay.
what I wanted.
Is that it? All right. We'll do class afterwards then. Yeah, I'm fine with that. Yeah, if you need extra paper, you can grab it now, or I will grab some extra paper if you need to. If in doubt, show your work. Even if not in doubt, show your work. Okay, so there, I got 2 people who need a calculator. Anyone else? 4? Okay. So, white paper and that was 4 calculators. other earphones?
Won't get any better.
Okay. Do you calculate?
Yeah.
All right, let's talk about momentum. I think all of you understand at this point. Just silence this. Alarm over there. All right, P equals mv. Well, two of the letters you should know, just we're tested on it. Tell me one of the letters and what it means.
Is M mass?
Take the question out of it.
N is mass.
Yeah, there we go.
And and V is velocity.
All right, we're on a roll. And that leaves the remaining one. What is P?
Momentum?
Absolutely. So we should have had you also remove the question mark. All right, and there's a PowerPoint that deals with this and has talked about it in videos, so I'm not going to go into the next lead. But power of momentum is, there are a couple of major conservation laws in physics. Conservation of energy is one of them. Conservation of momentum, or linear momentum, is another. Also, there's conservation of angular momentum, conservation of charge, and there's another one I'm blanking on right now. That starts getting into more obscure stuff. But this is one of the conservation laws, and the fact that in a closed system, I'll sort of write out momentum is conserved, the total momentum stays constant. Now this has, as mentioned last week, this has the power over energy, the fact that energy, you lose information about direction. Here we don't lose that information, but on the downside, we're dealing with vectors. We don't have the luxury of just ignoring direction. Sure, I am recording it for the others. All right. Let's see if we can get it to beat. Now, what do I mean by a closed system?
A closed system is a system that has factors and are not influenced by any factors other than the factors that you're accounting for.
Okay. All right. Ashley, you had your hand up also. You want to tweak that, Andy?
I was just gonna say it has no outside forces acting on the system.
Okay. So we'll spend a bit of time here looking at closed systems where we'll just have two objects. We don't have to worry about a planet or anything like that. And the marker's gone. Could use my finger. Oh, here it is. Might possibly I do that. So go back to where we sort of started here. I got some mass heading to the right, some mass heading to the left, and they're going to crash into each other. So let's say 5 kilograms, 3 meters per second, 7 kilograms, 2 meters per second. All right, so we have a formula over there, and so the little subscripts here, I got P for momentum, of course, because what other letter would you use? A, because I'm talking about mass A, and I for initial. So before the collision takes place, what is the momentum of mass A? We've got the formula right over there.
15.
Are you stopping there?
Oh,
What were you going with there? You said momentums?
yeah.
All right, what are the units?
Kilograms multiplied by mass.
Isn't it?
One more time?
Kilograms multiplied by meters and then by seconds.
Divided by second. So, in essence, a kilogram meter per second.
Kinda.
I know you said kilograms times meters, I think, per second.
Yeah.
Is the mass for V7?
Yes, it is. That is the unit right there. This is the first one we've come across where there's no one word unit for it. Now, if you prefer, you could also write down 15 Newton seconds. That's the exact same unit there. Slightly less writing. Or on a master set, if you don't want to do that, you could come up with your own symbol.
Wait, it's Newton's time second?
Yes, Newton times seconds. You're not buying it?
I just didn't understand how you pulled it out from the denominator.
A Newton, remember that F equals MA. So the unit of force is Newton, mass is kilogram, and acceleration is a meter per second squared. So if I multiply both sides by a second, I get Newton seconds here, and over here, one of the seconds cancels out, and I'm left with kilogram meters per second.
Okay, gotcha. Yep.
And you're allowed to create your own unit as long as you define it at the top of the page. And I go into, in one of the videos, I go into more detail than that. But if I wanted to just pick a letter that's not being used for any other unit, and I don't think we're using capital D for anything. And so if I define, in the 3 lines as I'm defining it, as a kilogram meter per second, then I could also write 15. Descartes. Rene Descartes did some work with us.
Could I point out another thing I think is missing from our answer?
What?
Is because it's a vector, don't we need to indicate that it's going to the right somehow? Whether that's by defining to the right is positive or by.
Okay, yes, and when I said what, I think I came across far harsher than I meant to. It was meant to be a much lighter, what are we missing? As opposed to, what? Maybe she has. Have you indicated direction?
Better probably.
There?
To
the right.
Newton seconds there.
Probably should do a little bit more specific for that. How do you want to indicate direction?
Positive sign.
So you want to make
Positive right.
positive right?
Positive there.
Okay, now, if we had just left this, so that's when I asked, maybe she already had, if she deliberately made it positive because she's defining that direction as positive, then she's done. If she just wasn't thinking about it, then, yeah, that would be incorrect.
Well, but in order for it to be correct, you would have to first define it as positive, so you're missing a definition.
Yeah.
of that.
Yeah.
I also didn't mean it as harshly as I said it, but.
All right.
I'm missing a definition.
If you had not asked that, I would have said, what has she just established that, but, okay, so now what is the momentum of B initially?
Is that a 7?
That is a 7.
14 Newton squares. 2 times 7.
All right, 2 times 7 is 14, I'll accept that.
Negative 14.
Ah, there's one issue. And the unit you said?
Newton seconds.
Okay, I heard Newton squared, sorry. Negative 14 Newton seconds or Descartes or kilogram meters per second, whatever your mood is at the moment. Once we establish that one's positive, this one's the other direction, because that's the problem. It's negative. Do not automatically assume that the second one's always going to be negative, because if they're going in the same direction, then they're both the same sign. All right, here's the part that really messes some people up. So let me erase some of this stuff. Apparently that was not the way to do it. Why? All right, here we go. Apparently I should draw again. Now, it's hard to tell with the letter P about what's a capital and what's just lowercase but written big. This is supposed to be a capital P. The distinction, and I don't always follow this, but the distinction in textbooks is that the capital letter stands for the entire system, whereas the lowercase letter stands for an individual part of it. So what I'm asking here is, what is the total initial momentum? Before the collision.
1 Newton second.
All right. Anyone have a question about how Ellie came up with 1 Newton second? Because she would be happy to explain, I'm assuming.
15 plus negative 14.
Yeah. Well, you're asking me, it sounded like,
15 plus negative 14.
there we go. Just add them up. Now, the tricky part. What's the total momentum after the collision?
Is it the same?
Yes. That's the whole idea of conservation. This is a closed system. I just have these 2 objects. Nothing else is interfering with it. The total momentum stays constant. My total is 1. So afterwards, it is 1. It does not matter what happens to them because it's a closed system. There's nothing else that's going to interfere with it. It doesn't matter what else, what kind of collision it is, that's my total. So now let's make it a particular type of collision. Let's make it perfectly inelastic. What does perfectly inelastic mean?
Neither of the two objects will give any amount whenever they collide with each other. So they'll just hit each other and remain exactly the same shape.
No,
Lose-
not necessarily.
Losing all the kinetic energy after collision.
They're not gonna lose it all. It's the maximum loss.
Okay.
So
Well, I
what-
would assume inelastic means it's not elastic,
Okay,
so it doesn't bounce off of each other.
which means,
It
Perfect,
stays in one place.
that would go, they lose all their kinetic
perfect
energy.
elastic thing, it's like when it keeps the same amount of kinetic energy and jumps back with the same energy. So perfectly inelastic, I feel like opposite to this, so it should not move after.
Well, it's gotta move afterwards because I have momentum. It's gonna be movement. Alright, so if they don't bounce, what are they gonna do when they hit?
Break.
And now you've made it a whole lot more complicated problem. So let's assume it's not gonna break. It shatters into 1,000 pieces. Where does each piece end up? That would be torture. Alright. Let's avoid torture till later. Part of it, the conversation's gone down a slightly different path than usual, so I was just